All right, welcome. It is now 10 o'clock in the morning, and my previously scheduled guest had to bail. Um, so I do have a little bit of time blocked out. So if anybody wants to have a conversation, informal conversation, all you have to do is email me at flatearthmath@gmail. First person to email me will get the join link. Hey, Blue Marble, how you doing? Do you want to have a little quick conversation? Do you have a microphone, or if you want to have a chat? I just have a little bit of time blocked out. So yeah, I don't know if you guys watched or listened to the hangout I had with Jimmy Jedi last night. Put me in, coach. Okay, so all right, it looks like ImRic is all right. Hold on a second. I gotta copy. All right, I'm sending you the join link via email. Okay. At least I think it's ImRic. Anyway, so so this is an interesting experiment of mine. I'm just gonna stick my toe in the water of social hangouts, but this thing over at Nathan Oakley's is really, I think, kind of gotten out of control. They're like, yeah, we want a more diverse panel, and then any Glober gets on, and if they don't kiss the ring and slobber all over it, they get booted off very, very quickly and treated extremely profoundly poorly. So yeah. Hopefully you got the link, ImRic. I have no idea what I'm doing, by the way. Alrighty. So hey, Spaceman. Oops, is somebody here? Uh-oh.
I'm very nervous.
It's ImRic. So let me do a really bad thing, ImRic. Let me give you controls. Yeah, so Spaceman, I appreciate all your your comments in the chat yesterday. I'm sorry, that is literally my avatar. So if you go to my channel, like that picture of a globe has been next to every comment I've made, next to every video I've made. That is literally my avatar. So if it upsets you, I'm sorry, but just think of Africa, okay? Think of how you descended from the tribes of Africa, and you'll feel better. Rhetoric and discourse. We have ImRic has shown up. However, this is this show is normally supposed to be with a glower. So rhetoric and discourse. If you would like to, if you would like a join link, flatearthmath@gmail. I'm happy to have a panel. Again, I blocked out a little bit of time, so we'll just run this thing until 11. So rhetoric and discourse. In fact, Spaceman, if you want to jump in, that's fine. My scheduled guest had a prior commitment, so yeah. ImRic, what's on your mind? I'm sorry. That's presuming. I'm sorry. That's a loaded question. Did you have anything written down, like on a piece of paper, that you might have glanced down at? Because I don't want to presume that you have a mind.
Well, I'm very nervous, and you're not really comforting me with talk like that.
Well, you should be nervous because don't look now, but over your left shoulder, you might find a red dot. That's actually the laser beam. I've got a sniper in your backyard. And so if you make any sudden moves, if you say the wrong thing, then we're just going to have to put you down. So.
Well, I don't know what you're talking about, but I I didn't watch your last video because I don't watch flat Earth stuff, but I bet it was great.
Of course it was great. Everything I do is great. And Blue Marble, I just sent you a link via email. This is my first time actually having an actual panel. So, but anyway, yeah, so ImRic, I don't know if you're familiar with Jibby Jedi, but he and I had a, I guess this is way, way back when there was actually a channel called, I forget what it was called. Was it called Flat Earth Debates? I forget. It was run by a series of people, and I think that's where I met him. And he always struck me as being very civil, and so I don't know. At some point, the two of us decided to have a debate, and it was very organized and structured. And in fact, I think it was self-moderated on Jibby's channel, and it was very well received. And after the debate, we then had a really long conversation. So it was kind of devolved into this. The actual file, the actual YouTube file, is like 8 hours long, but the debate part is only like 2 hours, 2.5 hours. But it was a good conversation.
Yeah, back when when I had lost my mind, I had listened to you talk to him. But now I'm sane, so I'm on my medication, so I don't listen to this. Oh, somebody's here.
Oh, Blue Marble. Okay, let me give you. So I'm giving people controls, so if they want to, do screen sharing or whatever. Here we go. So, Blue Marble, how are you? I don't think we've ever spoken.
Hey.
And is that a Super Mario hat on?
Yeah.
So Blue Marble, you have anything on your mind this morning, or I don't know what time of day it is and where you live?
It's 3 o'clock, and no, not really. 3 o'clock in the afternoon, that is.
Oh, okay. Where do you hail from?
England.
Okay.
He sounds Australian to me. I would check him out.
Well, Australia is actually located in England, so it's just they get the seasons reversed. But
Nah, Australia's fake.
oh, Australia's fake.
New
Okay.
conspiracy theory.
Yes, because people don't hang from their toenails. So, but yeah, you have anything on your mind, Blue Marble? Are you inspired by the NASA imagery of our fair planet? What's going on in your world?
Nothing much. Yeah, I guess so. I do like NASA. I'd like to work for NASA in the future.
Okay. Or what do you think about SpaceX?
Yeah, it's really cool. I think the idea to go to Mars is really cool.
Yeah, and they've really been pushing the boundaries. I mean, the whole idea of landing the first stage and recovering stuff, and now they're even working on recovering the second stage and then recovering the payload fairings. It's pretty exciting stuff. Just reducing the costs of launches. It's really an exciting step. So, Alex, if you would like a join link, we're just basically having an open panel this morning. My scheduled guest was not able to show up. So, Alex, if you would like to get a join link, just email me, and I'll email it to you. Oh, Spaceman. So Spaceman, you're welcome to come on the panel if you have a microphone. Otherwise, we can engage you with. Oh, and then Cosmic Surfer. Hey, Cosmic Surfer, do you want to join? You have a microphone? Just email me. I'll be happy to send you the link. Yeah, Spaceman, just email me. Flat Earth Math at email. So we're just going to run this thing until 11 a.m. It's just a very informal panel, just a couple folks, chatting up. So Cosmic Surfer, welcome. Oh, right. Okay, Alex. Fair enough. So yeah. So Alex, if you want to chat sometime in the future, just shoot me an email, and then we can set something up, because I'm in my summer vacation now, and I will be teaching summer school in July, but my time is fairly flexible. So okay, Cosmic Surfer. If you have you sell nonsense, Charles, no recovery. If you have any questions you'd like us to address, just type it in the chat. Yeah. Oh, thanks, Blue Marble. Yeah. Yeah. So nothing much is going on. I'm hoping to have a series of conversations. In fact, Cosmic Surfer. Oh, I've got an email from Spaceman. Hold on a second. Okay, Spaceman, you now have the link, so please join. Cosmic Surfer and Spaceman, my hope is with this civil discourse series of episodes is that I want to have a 1-hour conversation with preferably a flat earther, because when you get a bunch of globers getting together, it just is a big echo chamber, and I don't think that's any. I don't know. It usually devolves into just talking about flat earthers behind their backs, and I don't know. So what I
hate them both.
So and welcome, Spaceman. How are you, sir? I'm assuming you're a sir, but maybe you're a gal. But the hope is that this series of conversations, and I hope to have them be one-on-one, prearranged. Like I said, I don't like to have necessarily panels, going forward, but today was an exception. Okay. Angular reduction due to distance and the problem with elevation. So Cosmic Surfer, that's a very good point. The thing is, angular size, there are 3 variables involved with angular size, and it is distance, actual size, and angular size. And if you have any 2 of those 3 items, you can figure out the third. All right. So when you have the Earth curvature calculator, I know over at Nathan Oakley's, they've been, squawking about how they don't take perspective into account. But it shouldn't need to take perspective into account, because there's no target size. All you have is distance. So if angular size, or, the laws of perspective are based on distance, size, and angle, and you only have one of those 3 items, you can't make any computation. So if you only have distance, and welcome again, Spaceman, just say something. So if you only have distance, Cosmic Surfer, if you only have distance, you can't compute angular size. And so it's like the concept that something is getting smaller when it gets further away, that really has no bearing on whether there's Earth curvature, or whether it would be going behind the Earth curvature. All right, so who's presenting right now?
Oh, you talking about an angler, so I can show one.
Yes, angular size.
Yeah, big one.
Yeah. Well, good job, King Jong-un, or whatever his name is. That is so funny. But anyway, so Cosmic Surfer, the whole thing with an Earth curvature calculator is it's calculating the drop. It's not calculating the size of something, or it's not even calculating how big something appears. It's calculating the drop in absolute terms. So like, you'll get the drop in feet, and that those feet are measured at the target distance. So the real question, Cosmic Surfer, is if you want to apply perspective, why aren't people applying the angular size calculation to that drop? Because like, there's nowhere in the calculator that it says, oh, this lighthouse is 300 feet tall. Like, that's not in the calculation anywhere. Okay, forget the calculator. But I hope you see what I'm saying is like, if you, I mean, and you could do this on a basketball. That was one of the points I was trying to make last night, is that the Earth curvature calculator does not rely on the Earth. It just simply, you plug in the Earth's radius, and that's plugged in behind the scenes. But you could literally take the code of the Earth curvature calculator, and you could just change the letter R, give it a different value, and you could make it a basketball curve calculator. And all it will do is it will calculate whether, something is going to be behind the curve or not, and by how much. So Spaceman, you came in a couple times. Yeah. Do you have a microphone? Because you're in the Hangout. I don't know if your microphone's working. So no, we do not hear you, Spaceman. And you're not, it looks like, have you, no, you haven't muted yourself. You're, yeah, I don't know. Are you on a Mac or a PC? Because you can kind of test if you're on a Mac, you could test your mic by using the control panels, and then select sound, and then you can kind of see whether the bars are moving or not. Yeah, I don't know how to do that on a PC, but I'm sorry that it's not working. But you're live and in person on, as far as I can see, and you're not muted. So yeah. So Cosmic Surfer, yes, I've seen the pictures of the warehouse floor, but the problem with the warehouse floor is that there is zero guarantee that is perfectly flat. And when I say perfectly flat, I mean like mathematically perfectly flat. I've seen a lot of concrete pours, and when they pour it, they get it pretty close to flat. But it's, there's drainage issues, there's practical issues. There's no need for a warehouse floor to be mathematically perfectly flat. Like maybe if they were building a, superconducting super collider, they would bring out the precision instruments. But, if they're building a warehouse, they're going to make the floor flat to warehouse standards. Hey, Sean G, how are you? Are you interested in that? This panel is only going to run until 11. It's a very informal panel. My scheduled guest was not able to get here to get here. He had a prior commitment. So Sean G, if you would like to get on the panel, right now it's just me yakking my gums. Just send me an email. Flat Earth math at, can't even type, at Gmail. When they pour a slab, they don't pour flat. So, oh, okay, you can't at the moment. All right. Well, welcome to the chat, Sean G. We haven't spoken in a while. I remember the last time we spoke was a very good conversation. Yeah. So, hey, Sean G. The thing is, my idea behind this series of conversations is going to be inviting a flat Earth fellow on the panel, and then just having a 1-hour conversation. I get you, Sean G. Right. They can't pour flat for drainage. I get you. So, that's kind of my point, or part of my point that I was making to Cosmic Surfer, is that, the floor of a warehouse, may look pretty flat, but it isn't necessarily mathematically flat. Does anybody else have? Okay, so it looks like you changing your volume settings, Spaceman. Sorry that
I tried to change it.
Oh.
I tried to push him up all the way.
Yeah. Yeah, I haven't heard a peep. Okay, Spaceman. Oh, good enough. So yeah, Cosmic Surfer. I don't know if any of that made sense. Yeah, absolutely, Sean G. Yeah, the whole thing is, mutual respect. There's places where folks can talk respectfully, and then there's other places where, it just gets into a shouting match, and all this name calling and profanity. So yeah, much respect. Hey, Mitz is in the house. Determining the inertia of Earth spin. So angular, what do they call it? Angular momentum is an actual thing in physics. And for something the size of planet Earth that's turning, once a day, the angular momentum is massive. It's astronomical. Cosmic Surfer can I use AutoCAD? I actually learned how to use AutoCAD in what was the year? 1986. If you can go back that far, 1986. I was actually trained with a T-square and triangle, but they were just starting to come out with AutoCAD. But no, I haven't used it lately, and I think it's a commercial product. So why do you ask, Cosmic Surfer? I'm very curious. But Mitz's question about inertia, can you kind of clarify what you mean by the inertia? And so good to see you, Mitz. I haven't seen you in about 6 months. You're always a good fellow. And Mitz, will you have any interest in getting on the panel? Do you have a microphone? Because right now I'm just having an informal conversation. We're going to run this thing until 11. That's about 40 more minutes. Right now it's just me, exercising my gums. So Mitz, if you want to get on the panel, you can just email me, flatearthmath@gmail.com. I just lost my mouse. Okay. So Cosmic Surfer, if you can clarify what you mean by by AutoCAD, or what you're trying to get at. Because really, the whole thing with the Earth curve calculator, except for the bit about refraction, if you eliminate the refraction part and you just talk about the top calculations, that is 100% geometry. That is pure geometry. It has absolutely nothing to do with the actual planet Earth, other than the radius. Okay. So, ImRic, what's going on there?
It's an automatic Cadillac.
Oh, an automatic. Okay, so an auto. So it's an AutoCAD. That's an AutoCAD. Yeah. Okay. So Sean G, my hope is to do it every Saturday. No, I'm in my summer vacation now, so I have a bit of flexibility, but I've got a very patient wife, so I don't want to push the boundaries too far. But Sean G, my hope is that what I'll do is I'll arrange via email. I'll set up guests, like Jibby Jedi came on last night, and I had somebody for this morning, but he realized he had another commitment. So Sean G, I would be happy to have a 1 hour conversation with you, just you and me one-on-one, and just not really necessarily a debate, but just say what's on your mind, and just have a civil conversation is the hope of this channel. So if you would like to email me, Cosmic Surfer, use a neutral density. What is that? 100,000 filter. Look at the sun with your eyes. What size would you say it is? Yeah, well, it looks to be about 1/2 degree. Yeah, I like to get Cosmic Surfer. I like to get the I guess a solar filter, but I mean it's essentially the same thing as a neutral density filter. Foot-pounds. Moment of inertia. Yes, Mitz. So of course, of the planet, I mean, it's kind of like you have anything with a flywheel, any piece of machinery with a flywheel, and you can kind of reach out, and some pieces of machinery have a flywheel where the flywheel is exposed, and some of them you're actually supposed to touch it with your hand to kind of slow the machine down a little bit. But the bigger the flywheel, the more powerful the inertia, and it's tough to stop. So yeah, you can calculate it in foot-pounds, and no, a person will not have the power to oppose this force if we're talking about the planet. So ImRic, we will doing these 7 days a week, 15 hours a day all summer. Yes, that's over at ImRic's channel. Okay, Sean G. Yes, I'll check my email. and just, later on in the summer, like, we'll schedule it, when the time that's good for you, good for me, block out an hour. And, the title of the show is Civil Discourse. So, just a conversation. Okay. Parallel sun rays compared to your circle of sight from a point of view 1,000 meters high. So the thing about the sun's rays being parallel, they're essentially parallel, but the sun does have an angular size. So if you look at the sun, if you look at the top of the sun and then you look at the bottom of the sun, well, obviously those two lines of sight have an angle. The angle is 1/2 degree. So the parallel sun rays, it's like from the center of the sun. So for example, we talk about parallel sun rays forming, crepuscular rays, etc. But that's essentially measured from the center of the sun, or like the sun's average. So I'm not quite sure. So Cosmic Surfer, if you can kind of clarify this a little bit. Parallel sun rays compared to your circle of sight. And I don't know what you mean by circle of sight. Everybody's point of view is kind of like a dome or like a sphere around them. Most of the time, if you're standing on the ground, the dome is primarily above your head, but you could still look down and you could see, stuff on the ground. Cause you're the 360 VR guy. So that, so is that what you meant by circle of sight? Like the sphere of sight? And ImRic hasn't murdered anybody in days. Oh my goodness.
Okay, there, Father and the Son.
Okay. And what's the angular size of the sun? Can you tell
to
from
be
that
about
image?
2.6, something like that.
Okay. Yeah, because the angular size is measured in feet and inches. Yes, absolutely. Yeah, so Cosmic Surfer, I'm definitely interested in what your thought process is here. If you could just clarify a little bit. People talk about proof in the flat Earth debate, but there is no scientific proof, but you can gather scientific evidence. So, one piece of evidence is, I can see the sun and it's at this angle in the sky on this date, from this latitude. And that observation doesn't prove anything, but it is, it's an interesting anecdote. But if everybody does that, they see where the sun is in their sky, then you can kind of get a picture. All right. So Spaceman, welcome back in. Hopefully things will work for you. I'm really sorry that we can't hear you. Okay, at 1,000 meters high, you can see pretty far on the horizon. Then how does 0.5 degrees above your head light up the world around? Okay, so it looks like you're confusing the angular size of the sun with its ability to light up things. So, for example, if you had a 100-watt light bulb, and that 100-watt light bulb was, I don't know, 30 feet away, maybe 20 feet away. I'm just spitballing these numbers. That might appear to be 1/2 degree. Okay. So at a certain distance, a 100-watt light bulb will have the same angular size as the sun. Okay. But obviously the 100-watt light bulb isn't lighting the entire Earth, so just because it has a certain angular size, doesn't mean that, it can't light up the world, because, if you have a sun, which is, in the heliocentric model, it's a star and it's extremely far away. It doesn't have to be 93 million miles away, but if it's extremely far away and it's producing, a huge amount of light, then it will light half of our sphere.
Oh, finally it's working.
Yes. Spaceman.
Hey, how are you?
I'm doing quite well. Yeah, I'm so sorry that you had trouble. But I'm glad.
Yeah, I'm sorry that it looked like I'm very newbie, but it's first time I'm using this Google Hangout.
So
anyway,
welcome.
Yeah, thank you very much. I have to say that I really like your videos. I like the things you put in out there, the logic that you use in to prove your points and everything. Really, I think it's great.
Well, I appreciate that. So the thing is, I saw your comments, and I'm sorry I wasn't able to interact with you guys in the chat last night. So it seemed like you kept commenting on my globe avatar.
Oh yeah, why you putting this globe picture in front of us? I mean, are you a flat earther or what? Why to put this globe? You know, if you believe or think or measure the flat earth, so put a picture that how you say that going with your ideas and with your mind. You know.
Yes, that's what I've done. I've put a picture that goes with my ideas. So the
Globe
Earth is
picture?
the Earth is a globe, and so I've got a
Really?
picture of a globe as my avatar.
Oh, so you think the Earth is a globe?
I know the Earth is a globe. I've actually measured the shape.
Yeah.
I've tested the shape, I should say.
Oh,
I
what?
haven't measured the size. I've tested the shape.
You tell. Let me find something. There is some very smart scientist called. Let me find. I had his link. You can continue while I'm searching for it. But I will
Sure.
find you something. There is a scientist, very smart one, that came to the I don't know, to the mainstream science and asked them to make a measure of the Earth again because there's something wrong with the measurement, and they just kick him off. They don't want to hear about it, and they don't even let him sponsor to make this measurement. He did a really big work with the math, with proving everything to show what he mean about the measurement of the Earth.
Yeah,
Let
I'd
me
be
find
interested
the link.
in the fellow's name and the little
Yeah,
bit of
yeah, yeah.
history. So,
I was in his website last night. Let me find the link, and I will be with you. You can
okay.
continue while
Okay.
I'm doing.
So Cosmic Surfer, you said angular size is vital, but the thing is, the whole thing with perspective, you have three values. You have distance, size, or apparent. I'm sorry. You have distance, you have actual size, and you have angular size, and those three items are intimately related. And so just saying angular size by itself doesn't say anything. So if the sun has an angular size of 0.5 degrees, that doesn't tell us anything. A 100-watt light bulb has an angular size of 0.5 degrees if it's 20 or 30 feet away. Like, that doesn't say anything. You need more information. All right. So it says use a light source, forget about the sun, 100 millimeter light source, 1 meter from you, 1 meter from your face, and then take the light source away from you until it vanishes into the horizon. The thing is, it won't vanish into the horizon. No. I don't mean to say, Cosmic Surfer, I don't mean to say that angular size doesn't count. What I mean to say is that by itself, angular size, you could talk about angular size, but by itself, you can't necessarily say, well, draw some hard conclusions, right? So your example of taking a light source and then moving it away until it vanishes into the horizon, that's actually false. And you can actually test this with a cell phone, like the the flashlight app, because most cell phones have, little tiny white LED. I think I measured mine, and I think it was 2 millimeters in diameter. And
John Cozier, yeah, this is his name.
Okay.
So, let me find it. Where is it? His name is John Cozier. John Cozier. Yeah, look in Google. You will find his work immediately.
You just posted a link.
I posted a link to some YouTube video that talking about John Cozier, and there you have a link to John Cozier itself, and all his work and all his claiming.
Okay.
I mean, it doesn't say the Earth is flat, but it do say there's something wrong with the measurement of the Earth, and no one let him sponsor or let him the how you say, sorry about my bad English.
Oh, sure.
No one let him to go and do it, to tell him, okay, we don't care, shut up, go aside.
Yeah. Well, okay. So I'm gonna table this, at least because I want to do my homework. So I don't want to just kind of talk off the top of my head.
Okay.
I want to definitely look into this. But off the top of my head, when I've seen stories like this, it's like there's there's certain ways of doing science, using rigor, using repeatable experiments, and there's other ways where it's like what they call crackpot science, where it's just somebody talking off the top of their head without any empirical data. And so, so somebody will claim, like I saw a story.
This is not the case. He actually put there the form. You as a mathematician, I guess you will understand. He put their formulas and calculating and everything. You can download this PDF to see it. Everything he put in there.
Okay, and then I want to get back to Cosmic Surfer's point, but
yeah, sorry.
No. But what I want to say about, like, science versus crackpot science. There was a guy, somebody said, oh, this guy developed this water engine or something, and he claimed that he could run an engine just using water as fuel. And then so there was this big hubbub, and of course mainstream science was like, yeah, right, but somebody was like, well, why don't we test this thing out? And so, there was some professor at some university who was like, okay, I'm really interested in looking at your engine. Well, the next thing the guy, was like, oh, he all of a sudden it was unavailable. It was like, oh, I'm sorry, you can't examine my engine. So it's like, that's kind of crackpotish, so I'm very interested in this reference. I've got this, I've got the link up on another window, but I will definitely follow up with that, just not in the next 25 minutes.
Okay. It's
so
okay.
Thank you, Spaceman. So Cosmic Surfer, this is an actual test that you can do. And anybody listening, this is an actual test you can do. You can take your cell phone. You have a flashlight app. Well, first thing I would do is I would take a little ruler, a millimeter ruler, and try to measure the angular size of the actual LED. Like I said, when I measured it on my cell phone, it was 2 millimeters. And then I turned on my flashlight app. Oh, okay. Yes. There was. So I'm just going to post the link, and this is just the YouTube link. Okay. Water technology has been around a long time, 26 times more powerful than conventional fuel, by the way. Yeah, that's another story, Cosmic Surfer. But getting back to your angular size point, because it's a very good point, and it's one that's repeated in a lot of flat Earth videos about, like, how can we see the stars if they're so far away, etc. So you take your cell phone. First off, you need a piece of ground where you can go for a good distance and still see, like, if you go to a flat piece of land, and then maybe you have a safe place where you could put your phone, like maybe in your car window or something, and then you could walk away from it. I did this in the back alley. So what you do is you can calculate the angular size resolution of the human eye, which I believe is about a half arc minute, if I'm not mistaken, a half arc minute. So for example, the moon is about 30 arc minutes, and then you could resolve details on the moon that are about 1/30th of the moon or something like that. So first off, you could run the numbers and say, what's the angular size resolution of the human eye compared to a 2 millimeter light source, which is your cell phone, the cell phone flashlight. And I think I ran the numbers, and it was something like, and I'm just going to make this up off the top of my head, it was like, I don't know, it was like 100 feet or something like that. So if I get 100 feet away from myself, away from something that's 2 millimeters in size, it drops below my angular resolution with my naked eye. Okay. Okay. 0.2 degrees. I think it's maybe 0.2 minutes, because the moon is 0.5 degrees. So I think your human resolution is better than that, if you meant to write minutes, Cosmic Surfer. But anyway, my point. Oh, okay. My point is that you turn on your cell phone flashlight, and then you start walking away from it. And I was able to get something like 500 feet away from my phone. In other words, I was able to go 5 times the distance from my cell phone. And before I ran out of space, I was doing this in a back alley, and I literally couldn't go any further. I ran up against a wall. I couldn't do the test at a greater distance. At least I haven't tried it. But the point that I found for myself is that I was able to go 5 times as far as I should have. And not only that, when I was at the maximum distance from my cell phone, my flashlight, it was brighter than Venus. In other words, if I had more space, I could have gone 10 times the distance, right? I could have gone 10 times the distance and I would have still seen my cell phone flashlight. Okay. So my point, Cosmic Surfer, is that angular size resolution, it doesn't really apply to light sources or things that are reflecting a great deal of light, like the sun or the moon or planets, because those light sources are still producing light. If it gets so far away that the angular size is too small, the photons are still being produced. The photons are still going to hit your eye, you know? Yes, Bullwinkle, very good point. Avoid light polluted area. Astro Rex, that's pretty funny. Captain Soul asks a question. How do sun rays travel 93 million miles through cold space without losing all its heat through the environment? So Captain Soul, there are several kinds of heat. There's radiant heat, and then there's convective heat. So if you've ever been at a campsite in the, like when the sun goes down and it's gets kind of cool and there's a fire going, the actual air at the campsite might be cool, but when you face the campfire, your face will feel warm. And so your face is feeling warm, not because the campfire is warming the air, but because the campfire is producing radiant heat. So it's infrared. The infrared radiation, don't let the word radiation scare you. The infrared radiation is hitting your face, even though the air of the campsite is cool. Hopefully that makes sense. So Cosmic Surfer, photons, cartoon stuff. So forget the photons. Whatever the light source is producing that is causing you to see it, those things are still being produced, even if the angular size has dropped below your resolution. So like I said, don't believe me. Try this for yourself. Find a piece of ground where you could set up your cell phone, flashlight app, and then walk away from it. It would be great if you could find a location. Like I've been scoping out locations where I could set up my cell phone and then I can go like a quarter mile away or even a half mile away or, even further. And so that's like a side project of mine. Because I would be very interested to see for myself, what it looks like, what my cell phone flashlight looks like from a mile away. And Tinfoil Hatter is in the the solar wind. Yes. Tinfoil Hatter's in the house. Welcome. So we're only going to continue this for about 18 more minutes. I've got a hard deadline at 11 a.m. Eastern Standard Time.
Can I ask something?
Yes. I'm sorry. I'm just talking.
No, it's okay. Can you explain again how is the measurement is fit the fact that the horizon always going to your eye level on a globe? How is the measurement fit to this? Sorry,
but the horizon does not.
Talked about it before.
The horizon does not go to eye level. That's a phrase that gets repeated, but it's never been measured. It's never been tested. Well, I mean, it has been measured.
There is hundred of footage all over the internet of the horizon from every high you wish, from a plane high, from weather balloon high, from ground level, from. So how is that fit? I'm not saying you're wrong or something. I'm just asking how is that fit to the measurement? I mean, how is that logical to see the horizon in eye level if on the globe?
Okay, so and the thing is, there is a principle in human psychology where the eye is drawn to strong borderlines. So a truism, which flat earthers have picked up, a truism is the eye is drawn to the horizon. Like people have known that for hundreds of years, and so that they used to actually say the phrase, "The eye is drawn to the horizon." Because you're standing on the beach. I mean, like, where does your eye go? Your eye goes right to the horizon. Well, flat earthers have taken that very true statement. The eye is drawn to the horizon, and they've taken that to say the horizon rises to eye level. Okay, but this is testable. You can actually test whether the horizon rises to eye level, and it does not. You can measure it. You get it.
So in which height we're supposed to see the curvature of the Earth?
Well, okay, so that's a different question. So
yeah,
I want to put horizon rises to eye level to bed before I address that. The thing is, do you know what a hydrostatic leveling tube is, or even like a water level?
In general, yeah, but not in a professional way. But in general,
in
yeah,
general.
I know what it is.
Right. So there's a video, and I don't want to take the time to search for it now, but a guy, he basically takes a tube, but he sort of makes a square out of clear tubing. So it's sort of it's a continuous tube. The tube is end to end, and it's half full of red liquid. So he and it's mounted in like a wooden frame, so he can carry it around. And so he first takes it to the beach, and he sights along the water level, and the horizon looks like it's approximately at eye level at the beach. And then he takes it up to, I don't know, 1,000-foot cliff. And he looks out at the horizon, and the horizon is definitely below eye level. And then he goes up to some, I don't know, Mount Shasta or something. He's in California, and he sights again, and the horizon has dropped even further below eye level. And so this is just with a little piece of clear tubing and some red liquid.
So,
yeah.
Okay. So I'm asking. So in which height I supposed to see the curvature of the Earth if I don't see it in any way? So in which height? Yes.
Yeah. Well, again, that's a human perception question. My best either guess or from evidence is like above 40,000 feet. You could start to perceive it with your eyes. My understanding is that.
But there's a footage of weather balloon camera in 100 feet, and you don't see the curvature. So
no, I've never seen a lack of curvature in any high altitude footage.
I mean the amateur high altitude footage, not the fisheye lens of NASA high altitude footage.
All right,
amateur people that send regular camera with regular lenses.
Yeah, no. The thing is, fisheye lenses weren't made by NASA. GoPro.
Yeah,
GoPro is.
I don't say that made by NASA. I just say that all the footage of NASA are with fisheye lenses, and footage of normal camera doesn't have the same curve that they have. So
okay, so
something here is not right. I don't know.
Oh, okay.
Can I just point out that?
Go ahead.
Can I just point out that just because NASA uses fisheye lenses doesn't mean that the Earth is flat.
I don't say the Earth is flat. I just say that in every footage of NASA, they use only fisheye lenses, and every amateur balloon that's sent into space or into the atmosphere with their normal lenses, you don't see the same image that you get from NASA. I don't say the Earth is flat. I just say that something here is strange. Okay, here is the classic footage. Here I will put in the chat. It's classic footage of the dog cam. Yeah, which is with hold
on a second.
It doesn't let me to send. I will put it here. I will put it in the Google Hangout. Yeah, so you can see it.
There it is. Yeah. Okay, so
now it's not only showing a flat horizon. Okay, it's like in I lost the height, and it's getting until how much? 33,100 meters. I'm not sure how many feet it is, but you still see everything flat, and you still get a warm spot from the sun. I mean, it's. Can I not trust my eyes? That's what you say. That what my eyes showing me is not the truth. I don't understand it.
Okay, so
warm spots aren't caused by the sun being closed. They're just because clouds disperse the light coming from the sun into the camera. But
let's say that I believe it, which I don't, because it is closed because the sun is closed. There's no other way for it to close. So why only on these clouds? Why not all other clouds there is around there in this footage? There is only one hotspot. This is not, if it was as you say, we're supposed to see many hotspots. I mean, the sun is huge now, so we're supposed to see many hotspots from your theory. But the
The
only thing
sun's
I see
also
is one
pretty far
hotspot.
away.
Okay, let's say the sun is far away, but can you explain that this a normal camera, we don't see any curvature? We don't see anything. I don't say the Earth is flat. I just say why I don't see the curvature. But
So-
NASA fisheye lens camera, yeah, we can see the
Okay,
curvature.
so Spaceman. There's tons and tons of ways of determining the shape of the Earth, and I think a lot of people get hung up on fisheye lenses. But even with a fisheye lens footage from a fisheye lens, if the horizon crosses the center frame, the exact center frame, like the exact middle, left to right and top to bottom, you could see the true shape of the horizon. Now I'm looking at this dog cam footage, the link that you provided in the side chat, and I'm at 4 minutes and 23 seconds, and I could see the curvature of the Earth in that footage. The horizon is crossing center frame, and I could see the curvature.
Oh, you see, because I don't see, so maybe my
Yeah.
eyes are not showing me. I don't see any curvature. I mean, and you can see that it's going around. I mean, it's making a video of a very huge surface of the Earth. But
yeah, now the other thing is, so I hope you get my point about you could take a look at any of this amateur footage, find where the horizon crosses the center of the frame. And then you'll see the true shape of the horizon. Now everybody, it's now 10:51. We're going to go for about 9 more minutes, and then we've got a hard deadline. I want to thank everybody for all your very kind comments in the chat and keeping it civil. So thank you. We're going to go for about 9 more minutes.
okay.
So Spaceman, the other thing you said was hotspot.
Yeah.
Now hotspot is a term from photography when you have a light source that's too close to a flat surface, and because of the light falls off with the square of the distance. So if a light is like close to a wall, you're going to get a very bright spot on that wall. It isn't necessarily hot as in temperature hot. It's very, very bright. Now, when everybody shows these hotspots on these high altitude balloon cameras, it always seems to be a reflection to me. Like sometimes it's actually in water. You can actually see the reflection in the water. And then the other thing about that is that the launch of this balloon, like sometimes they've actually analyzed the geography. So there was one famous balloon, I forget which one it was, but it was launched from Germany, and then you're like, oh, okay, so here's the coastline of XYZ country, and you can recognize the actual shape of the coastline. You compare it to a map, and then there's this big hotspot, right? And it turns out that means that the sun would be directly overhead off the coast of a European country. And it's like, no, the sun has never been 90 degrees overhead in any European country. It has never, ever happened. And so, and there was an even worse one. It was like Poland or something. It was even further north, and there was a hotspot, a quote unquote hotspot. And it turns out that it was like, all right, so the sun was not 90 degrees overhead above Poland. It just doesn't happen. Does that make sense? It's a reflection. It's not a hotspot.
And also, if you have an object reflecting light,
Yeah.
and the object has a hotspot, if you move around, the hotspot will appear to move around on the surface of the object that you're looking at, because that's the light coming from the object bouncing off the other object that's reflecting the light into your eyes.
So what do you say? I have no way to measure the curvature with my eyes or with camera, with anything. Just with a mat that we already know that somebody told us. If I want to measure it myself, to see it with my eyes, what should I do to see it?
Okay, can we distinguish between a curved horizon and the effects of curvature? So the thing is, human beings, compared to the size of the planet Earth, we're infinitesimally small. We're smaller than a fleck of dust on a basketball. Like I think I ran the numbers. If you take a piece of salt, a grain of salt, and put it on a basketball, that grain of salt is actually a cube 7 miles high. So human beings are just infinitesimally small. So the desire to see a curved horizon, I totally get you, but we are really, really tiny. So the only way you're going to see a curved horizon is if you get really, really high up. And like I said, every time I analyze these high altitude balloon footage, high altitude rocket footage, every single time I see the curvature of the Earth. Now you have to analyze it properly. You have to wait for the horizon to cross center frame, but I've seen it every single time. Now that's one thing. The other thing is you could see the effects of curvature here on the ground, but you have to perform, a proper test. And one of the best tests I've heard of was one done over 100 years ago by Alfred Wallace at the Old Bedford level, where there was these two bridges and he hung a banner 13 feet above the surface of the water with like a big black bar that was 13 feet up. And then so the bridges were 6 miles apart on the Old Bedford level canal. And then at the halfway point, at the 3 mile point, he stuck a post in the ground, and he had a disc, like a black disc, a circle that was 13 feet above the water. So he has, one banner at one bridge, a disc in the middle, and then a banner at the other bridge. And then he took a telescope. I think it was like an 8-inch, reflecting telescope. And then he sighted along to the far banner. So the telescope was 13 feet high, and he was sighting along to the far banner. And what he found was that the disc was higher. So when you sight from end to end 6 miles, you're going to actually see the curvature of the Earth, because the post in the middle was supposed to be, along the sight line if the Earth is flat, but it was higher. It was like 5 feet higher than the sight line. So that was a visible demonstration of Earth curvature in 6 miles. But we're really tiny. And we're gonna shut this thing down in about 4 minutes. So, folks, in the Hangout, do you guys have any final comments? Spaceman, I really appreciate your comments, and I think
and next time when you make in another live, if you join in people like this randomly, I will love to ask you many more questions.
Yeah,
to get your answer.
Okay, so but here's the thing, Spaceman, I would be happy to have a 1 hour conversation with you. Just
I'm
email me.
I'm not debating. I'm just asking
no.
a question to understand, because
yes,
you know that it's strange that I have a question. I mean, if the Earth was clearly a ball, so why we have so many questions that we cannot identify it? But we don't get to this subject because we don't have many times. But I would love to speak with you about it one time.
Yeah. So I just want to clarify one thing. It's not clearly a globe. It's clearly flat, right? Human perception says the Earth is flat. So it's not clearly a globe. You could test the shape, but it's not clearly a globe. It's clearly flat, but you can actually figure out that it's a globe. But thank you very much, Spaceman. I appreciate your questions. Blue Marble, you guys have any? You have any final comments? We've got about 2 more minutes.
Subscribe.
Subscribe. Okay. And if there's any flat earthers who are listening in the audience, I'm absolutely happy to have you email me, flatearthmath@gmail.com. I would love to set up a 1 hour conversation. And I want to clarify, Spaceman, I'm not talking about debating. I don't mean a 1 hour debate, you versus me. No, I'd be happy.
I'm not debating. I'm not in your level of education. I want answer to my questions.
Sure, and I'd be happy. No, Spaceman, that's what I meant. If you want to have a 1 hour conversation where you ask questions and I try to clarify things, that would be fine.
And I will make all the question in advance, that everything will be clear and organized and everything. It will be my honor to do it.
Yes, no, absolutely. So what I'm just saying is, please email me. Well, you've already emailed me for the link. But like say pick a date, 2 weeks from today or something.
You can pick the day. I'm available. It's okay. Pick the day, pick the time, tell me when, and then we will.
Alrighty, I'd be happy to have a conversation with with just you and not a whole panel, and that'll be fun.
Yeah, sure.
Right. So we have 1 minute left. ImRic, I really appreciate you moderating and putting all those images up on the board. Do you have any final thoughts?
No, subscribe.
This is everybody thought. Yeah.
All right, so it looks like that's just about it. It's now 10:59, and I think we're going to wind this thing down. I want to say a big thank you to everybody. Yes, thank you to Spaceman, to Blue Marble, to ImRic.
Be in touch in email, okay? So we find the day to do it.
Yes. Let's do that. Great. And a big thank you to everybody in the in the chat. And please vote for me in Nathan's DFOTY contest. All right. Take care, everybody. Goodbye.
Bye-bye.